The topic is triple integrals in cylindrical coordinate. So let's read the definition. Definition says, if we want to convert from rectangular coordinate to cylindrical, we use x equal r cosine theta, y will be r sine theta, and z stay the same. We also know that if you square x squared plus y squared will give us r squared. And then to evaluate triple integral over a solid E of a function f of x, y, z dv, this is how we do it. All we do is change every x by r cosine theta and every y by r sine theta, and z we do not touch, and so on. So let's do this example. Evaluate triple integral over the solid E of x squared plus y squared dv. So remember, this is your f of x, y, z. Even though the z is not in there, that's a function of x, y, and z because we're using triple integral. Where the solid E is enclosed by the plane z equal 1 and the cone z equal, so we have plane z equal 1 and the cone z equals square root of x squared plus y squared. So let's draw the solid. So here's the cone, right? So this is going to be z equal square root of x squared plus y squared. And then the plane z equal 1, we're just going to do a line, but you have to picture that it's actually a plane. So this is 1. Why do I write 1? Well, let me do it this way. This is the plane z equal 1. Alright, so let's do it. Triple integral e over e of x squared plus y squared dv is equal, we always start from, let me leave the space. We always start from the inner integral. So that will go, we want the z, so the inner one will be r is going to be there, don't worry about it, so dz. Right, since we have a dz, so those limits of integration are going to go from z equals something to z equals something else. So we're going from here to here, the solid. So we're going from z equal square root of x squared plus y squared, and then we go into z equal 1, and our function is what? X squared plus y squared, right? And let's just write dA here, but of course we want to have dr d theta for now. So how do we know dr d theta? We need the reflection or a projection of our solid on the xy plane, and you can even see it. It's going to be this circle that's going to be projected. That's the reason. So it's going to be, in other words, this disk. So how do I do that? Just plug in z equal 1 into the equation. At z equal 1, we'll get that projection. So if you square both sides, you get x squared plus y squared is equal 1, which is 1 squared. So we get a circle. So let me draw the circle here. In other words, the region will be this disk of radius 1. Right, negative 1, 1, negative 1. Right? So let's do, what do we usually, so let's call this over a region D. And this is what we mean with D, that disk inside. So if we try to do D in polar, and that's what it is, D in polar will be what? The radius is going to go from 0 to 1, and the theta will go from 0 to 2 pi. So let's call this 1. So 1 will be equal, the theta is going to go from 0 to 2 pi. The radius is going to go from 0 to 1. the z is going to go from square root of x squared plus y squared to 1. We're going to replace that also. X squared plus y squared r dz. Now this is going to be dr d theta, right? Because theta is the outside one. Alright, let's make sure I didn't make any mistake now. Now we're going to use these equations to replace x and y. So we know that, let me rewrite it, equal 0 to 2 pi, 0 to 1, and square root of x squared plus y squared. Remember, x squared plus y squared is equal 1. Square root of x squared. X squared plus y squared is equal r squared. So let's replace the inside by r squared, which is equal to r. Right? I'm using that. So that will be, what did we say? That would be r. So it's going to go from r to 1. And then x squared plus y squared is also r squared times this r. Don't forget about the r. And then dz, let me do this, dr d theta. So this is just r cubed, right? So this will be equal to 0 to 2 pi. The rest will be so easy. The r will go from 0 to 1. Now remember, this is r cubed, but we take an integral with respect to dz, so r cubed is considered a constant. So that would be r3z between r and 1, dr d theta. That should be equal to, we're going from 0 to 2 pi, 0 to 1. Now plug in 1 and r for z. So if you plug a 1 for z, you get r3. Minus, you plug in r, you get r3 times r, which is r4. dr d theta. And this is going to be equal 0 to 2 pi. Now we're doing the inner integral. So the integral of r3 with respect to r, that would be dr would be r4 over 4 minus r5 over 5, and that would be between 0 and 1, d theta. Now plug in a 1, 1 to the 4th is 1, so it's 1/4 minus 1/5, minus 0, we don't have to write that one. So 0 to 2 pi, d theta. The inside will be what? 5 minus 4, 1 over 20. Let me do it in 2 steps. 1 over 20 d theta, which is theta between 0 and 2 pi. Well, not theta, 1 over 20 theta, right? So plug in the 2 pi, you get 1 over 20, 2 pi minus 1 over 20 times 0. Simplify 2 with the 20, you get pi over 10. And that's it for this example.